For some reason, there's this part behind me that just, for some reason, keeps on following me wherever I go. So if I walk in any direction, no matter where I go, this part literally keeps following me behind my character, specifically behind my back. And it's really crazy how it's able to determine exactly where to position itself and where to orientate itself while it keeps on updating and following my character behind my back. It's actually really interesting. Let's see what's happening behind the scenes here. Alright, let's think about this for a minute. If we open up the script that basically is managing this part's position behind my character right now, let's see what's going on inside of here. Okay, let's actually get rid of this part. This part is just irrelevant for what we're trying to discuss here. But yeah, basically, this entire thing is being run by only 4 lines in this one single while true do loop. What is happening here exactly? So we have the part, and we have this property here called a CFrame, and we're updating the CFrame every 0.01 seconds to follow the CFrame of our character's torso. And it's using this weird method called ToWorldSpace with this little weird constructed C-frame right here that's constantly updating every single time. Don't worry if you don't know what any of this means right now, but I just want to point this out that what we're doing here with our character is we're updating the C-frame of this part to constantly be behind my character's back. And it's one of those data types that's really, really important to know about for if you're trying to position and orient 3D objects inside of the workspace. And that's basically one of the key definitions of using C-frames. It's to position and orient 3D objects inside of the workspace. And we can do this with very precise calculations to help us understand the 3D world more by doing this. And that sounds a lot like vector 3s. I'm going to explain what the difference between C-frames and vector 3s are in a little bit. But with that being said, now that we have a general idea of C-frames, let's go ahead and start implementing it. Now that we understand it, let me quickly reiterate what a C-frame is. A C-frame is essentially a data type that acts as coordinate frames that allows us to rotate and position a 3D object inside of our workspace. So this sounds pretty similar to vector 3 when we're trying to change the position and orientation of a part, but think of C-frames as a combination of position and orientation at the exact same time under a new data type that Roblox has created, which of course is called C-frames. So let's say I inserted a part here inside of the workspace, and remember that we have 3 axes inside of the workspace. We have the z-axis, then we have the x-axis, and then the y-axis. We have 3 directions that we can pick from when we're modifying any object or part inside of our workspace. And we can pretty much do the same thing when we rotate the part as well. We have 3 axes to work with when we're rotating the part in whatever direction we're trying to change it to. And so when we essentially combine rotation with position, we get C-frames, and that's how we're able to make really precise, really complicated object modification inside of our 3D workspace. So that is basically what I'm going to be showing you how to do inside of this video. And so now that we understand that, let's get to implementing it. So since we have this part, let's go on the right side and let's rename this part to CFrame part. And let's also change the size of this part to 4x4x4, and then let's change the brick color to probably some sort of blue, like really blue. All right, so now we have this part, and also what we're going to do is make sure to check the anchored property as well. So now that we have that, what we're also going to do is change the position of this part to its origin, which is going to be 0, 0, 0. So you can find that under here in the transform C-frame property right here. And now it should be over here. So now that we have this, let's actually try to change its coordinate. Let's try to change its C-frame. So once again, a C-frame can basically manipulate the position and rotation or orientation of whatever object we're trying to work with inside of the 3D workspace. So let's say I wanted to move this part away from the origin, and let's say move it 25 studs in the Z direction right here. What we would do is we would create a new C-frame object that we're basically going to apply to this part's current C-frame so that we can update it to be inside of this C-frame rather than where it originally was over here. So what we're going to do is we're going to create a script by going to the right side, hitting the plus sign in front of the part, and then we're going to hit script. So let's delete this. Let's make reference to our part by saying local part equals script.parent. And so now what we're going to do is we're going to create a new CFrame object. And the way this is going to look is this is going to use a constructor for it. So we're going to say local new CFrame equals CFrame.new, open and close parentheses. And you remember how for the position coordinates that we're trying to change, we're just saying that we want it to be at 0, 0, 25 as the new position. So when we create a new CFrame, one of the ways we can create this is by simply putting in the three XYZ position coordinates that we want to give it. So it's going to be 0, 0, 25. So this is going to be the new CFrame that we want to update this part's current CFrame to by doing so down here. So let's drop 2 lines, and now all we need to do is say part.CFrame equals new CFrame. So this is pretty much everything we need to do in terms of that. Let's go into the game and let's hit test and hit run to see our result. So as you can see, when the game ran, we changed the part's CFrame to the new positional CFrame that we made it out to be, being the position 0, 0, 25. Now, of course, this is one way of creating a CFrame. It's just by adding in its positional coordinates to whatever the new one is we're trying to set the part to. But there's many other ways we can utilize this new CFrame constructor to do other things like change its position, but also change its orientation to create more complicated calculations with this sort of stuff. But this was just a basic example, and I hope you understood this. Now let's say we wanted to change the orientation of this part using CFrames and not by changing the orientation property itself. So I hope at this point you remember how rotating 3D objects work, at least inside of a script. So we basically start at the origin at 0 degrees, and if we want to update the orientation of a part, then we have to specify the angle that we want to change whatever axes we want to change the orientation to. So we start at 0, and then when we go clockwise, it's going to rotate like this every 45 degrees or however many degrees you want it to until it goes all the way around, going back to 0 again, or 360 degrees in this case. So with this in mind, we're able to create a CFrame and change this for ourselves inside of the scripts that we're trying to change the part's orientation to. And I'm going to show you what that looks like using CFrames. So let's go inside of our script. And what we're going to do is we're going to comment out this previous new CFrame, and we're going to create a new CFrame right here. And what we're going to do on the right side is we're going to use a method from CFrame called CFrame.angles. And this is basically what it's going to look like. So we're going to say CFrame.angles, make sure it's in it's uppercase, and then open and close parentheses. So now what we have here is an orientation method that we're able to pass down 3 arguments here for the degrees that we want to the desired orientation that we want to give it. Now here's the thing. Angles by default is in the units of radians, and if you don't understand what radians are, they're basically a different metric of orientation compared to angles. So those are like two separate units of measurement. By default, it's in radians. So what you want to do instead of using radians is convert our degrees into radians using a method called math.rad. So let me show you what this looks like. We're going to say math.rad, open and close parentheses, and then put in our degrees that we want to put inside of here, which is in this case going to be 45 degrees, because as you know, if we go 45 degrees, then it's going to look like this. So this is what we want to have. So this is what we want the script to do. But this is in the y-axis, not in the x-axis. So we have to make sure that there's a 0 before whatever is here in the middle. So let's make another comma and then put in 0. So this is basically our new orientation CFrame exclusively. This is specifically for orientation, not for changing the position of the CFrame. This is one way of writing the new orientation CFrame. So let's go into the game and hit run to see what happens. All right, and as you can see, the part is now rotated 45 degrees on the y-axis. If I open up the properties for this part, we can scroll down and see that the orientation is now successfully at 0, 45, 0 for the new CFrame that we updated using CFrame.angles. So I hope that made sense to you. There's one really cool feature about CFrames that we can use, and that is making a CFrame that allows a part to look directly at a specific position that we give it. And basically what we're going to do in this example is we're going to use our current part to make it look directly at another part's position when we apply the C-frame to our blue part here. So what we're going to do is we're going to move this blue part alongside this direction so that we can actually see it better. Let's also add in a decal in front of this part so that we know that the front is facing in the right direction. And what we're going to do is we're going to go to the right side and let's right click, duplicate, and let's move the part over here. And let's rename this part to look part. And let's also change the color of this to probably like red or something. And let's open this up. Let's get rid of the script that's inside of here. And now let's go back to our current script. So inside of our current script, what we're going to do is let's uncomment out this part here. And let's also comment out this too. So what we're going to do now is make reference to the look part. We're going to say local look part equals workspace colon wait for child look part. And basically what we're going to do is we're going to create a new C-frame that has two things included with it. So the first one is its starting position, and the second one is a vector 3 that specifies the position of the part that we're trying to look at. So what this will look like is we're going to first write our starting position vector, our starting position, also known as a vector 3 value. We're going to say local start position equals part.position, and then what we're going to do is we're going to specify the position that we're trying to make the part look at. So this is where look part comes in, where we're going to say local look position equals look part.position. And so what we're going to do now is we're going to drop two lines down here, and now we're going to create the new C-frame that we're going to apply the part to. We're going to say local new C-frame equals CFrame.new, and this is going to be another way we're going to write this. So the first argument we're going to put in is our starting position. So we're going to copy that and paste it into here, and then it's going to be another vector 3 value, which is going to be the look position of our look part, so we can put that in here. And this is basically our new C-frame right here. So if we drop two lines down here, say part.cframe equals new C-frame, we now have our desired result for what we're trying to do. We're first giving it a start position of this part right here, which is basically just where it currently is right now. Like right now, the position of this is 1826. It's going to start here. But then we specify a look position that is basically saying we want this part to look exactly in this direction to where this part's position is currently at right now. I hope that makes sense to you. Let's go into the game and hit run so that we can actually see it for ourselves. And there you go. The part is basically in the exact same position as it was, and it's now looking directly at the position that this part is in. So this is a really neat feature we can use with C-frames. And so I hope this part has allowed you to understand another useful feature about C-frames. Another thing we can do is combine multiple C-frames together using CFrame Operations. So basically, if let's say we were currently here in this position at 1826 with this part, let's say we wanted to take it to where it currently is right now to, let's say, negative 25 studs in the X direction here. So how can we do that? How can we start from here where it currently is to offset it 25 studs this way rather than starting from the origin? What we can do is we can combine C-frames together to get the result that we want to when we're offsetting a part's C-frame. So what we're going to do is we're going to go back into the script. Let's comment out everything we've done up until this point so far. And let's drop two lines at the very end down here. So what we're going to do is we first need to get the current C-frame that the part is already in right now. So what we're going to do is we're going to say local part position equals part.position. Next thing we're going to do is we're going to create a new C-frame using the information that we have here with the current part position plus a new vector 3 value in order to make this work for us. So what we're going to do down here is we're going to say local new position equals part position plus vector3.new, open and close parentheses, -25, 0, 0. And finally, what we're going to do is we're going to set the parts CFrame. So part.CFrame equals a new CFrame, because what we have right now is a combined vector3 value. What we're going to say is CFrame.new, open close parentheses, new position. You have to make sure that you wrap this new position inside of a CFrame, otherwise we're going to get a mismatch error because we're not trying to make this CFrame equal to a vector3. That's why it's very important to change this into a CFrame. Okay, wait, I meant 25, not -25. So let's go into the game and hit run so that we can now see the change that's going to happen with this part. So there we go. We basically started from where it currently was, and we added 25 to its X value so that it now went inside of this direction, rather than starting from the very origin. It started from where it currently was to give it an offset so that it can move to the new position that we specified with the C-frame. So that's pretty much how you make an offset when it comes to changing a part's position. All right, but here's also another important thing that I should note here is that what we did was that we added 2 vector3 positions and created a new C-frame off of this. But what if we wanted to make it so that we literally take the C-frame of the part directly and we added a new C-frame on top of this C-frame? So there's another way of doing this rather than having it like this. Let's comment out this part so I can show you another way of doing it. So what we're going to do down here is simply say part.CFrame equals part.CFrame. So we're literally just taking the exact C-frame that this already is in, and we're going to add another C-frame on top of it. But here's the very important thing to know about. We're not adding C-frames necessarily, we're multiplying C-frames to other C-frames, and that's essentially how you quote-unquote add C-frames. It's a very important distinction to know about with C-frames that are not the same way of doing with vector3 values. So here we can create a new C-frame data type to add on top of the part C-frame by saying CFrame.new, open and close parentheses, 25, 0, 0. And this right here basically acts exactly the same way as we did up here. Rather, the difference here is that we combined C-frames rather than combining vector3 values. So if we go into the game and hit run, we should get the exact same result as we did when we combined positional values rather than C-frame values. So I hope this made sense to you as well. Like I said, one important distinction to know is that when you're combining C-frames, you use the multiply or the asterisk symbol instead of adding it, because adding is a vector3 property, not a C-frame property. Alright, so this next part's going to be a little complicated, so I want you to fully pay attention to this, and I'm going to try to explain this to the best of my ability. But so far up until this point, we've basically been manipulating C-frames of 3D objects based around the world's perspective. But we can't rely on the world's perspective every single time we're trying to change a C-frame of a 3D object. Because let's say we had this part right here, and we decided to rotate this part 45 degrees on the Z-axis. What we'd want to do is, if we want to further make changes to the C-frame, then we would have to make it relative to whatever the orientation and position this part is already in. Because now, ideally, the X, Y, and Z axis should be facing this way relative to what the orientation and position already is. But that's not the case here, because if we're doing this based solely around the world's perspective, the X, Y, and Z axis is still looking like this. But what we want to do is make it look like this instead, relative to the current position and orientation of the part. Oh, and by the way, if you're wondering how I'm able to change the relative and global axes, I basically hit down Control L. I think it's Command L on Mac, but now what we're doing is we're setting up its local axes to be able to change this stuff. But if we want to change it back, we can just hit Control L again. So now it's in the world's perspective and not the relative parts perspective. So I hope that analogy made sense to you, understanding the difference between local and relative, or global and relative C-frames, because that's what we're going to try to do with this example. We're going to try to change it based on its relative C-frame, not the global C-frame. So let's say we wanted to change the relative C-frame of this to move -5 studs on the y-axis in this direction. What we're going to do is we're going to go to our script and we're going to use a method that CFrame has provided to us called ToWorldView. So this is what it's going to look like. Let's drop 2 lines down here and let's say part.CFrame equals part.CFrame. So we're taking the exact same CFrame that this part is already currently in, and we're going to use a method called :ToWorldSpace, open and close parentheses. And what we're going to do here is we're going to pass in an offset CFrame. So basically, if we started here and we want to move it in this direction by -5 studs on the y-axis, what we would do is we're going to create a new CFrame and pass it into here as the offset CFrame. So what we're going to do is we're going to say CFrame.new, open and close parentheses, 0, -5, 0. And now we have our relative position where the part currently is, and we're going to give it an offset of -5 on the y-axis so that it can start where it currently was and then go -5 studs in the y-axis. So let's hit run and see what happens. I keep messing this up. It's not -5, it's just a regular 5. So let's go into the game and hit run to now see our change. So we were able to successfully change the y-axis of its current CFrame to be relative to where it currently was and not have it based on the world's perspective. It was from the perspective of this part. So I hope that analogy made a lot of sense to you, and I hope you now understand the difference between global and relative CFrames, because this is very, very important when it comes to perspectives when changing CFrames. CFrames also have these neat properties that allow us to determine the direction that a part is facing. And we can actually use these properties knowing which direction that the part is facing to create accurate calculations to the position of the 3D object that we're trying to manipulate. So there's 3 properties that I'm going to introduce in this video. The first one that I'm going to introduce is LookVector, the second one being raycasting and UpVector. But the most important one I think you should know about is the LookVector. So as you know, 3D objects have different faces. So we have a front face, a back face, a top, and you basically get the idea of the rest. So when we're determining the LookVector, it's basically the direction that the front of the part is facing. So in this case, where this little decal is, this is the front of the part, and it's facing in this direction. So it basically returns, or LookVector in this case, returns a vector 3 telling us which direction this part is facing. And we can use this property to then say, okay, what if this part is over here and we want to move this part in wherever this look direction is and make it go in this direction based on however many studs we specified using a multiplier. That's what we're going to do inside of this script using its LookVector property. So inside of the script, let's comment out this part right here and let's drop 2 lines. So in order to know the property of the part's LookVector, what we're going to say is local LookVector equals part.CFrame.LookVector. And that's basically what this is right here. It's a vector 3 value that consists of 0s and 1s that tell us which direction inside of the world that this part is currently facing. So what we're going to do now is we're going to take the part's current position and specify its LookVector and use a multiplier to then tell us to make it go in this direction with however many studs we decide to give it. Because if it's facing in this direction, it's going to give us a value of 1, and we can use a multiplier to specify how many studs we want it to move this way. I think you'll see what I mean when we actually get to scripting this. So let's go back to our script, let's drop 2 lines down here, and how this is going to work is we're going to say part.position equals part.position plus, and then we're going to wrap this around in parentheses. We're going to say the LookVector, and now what we'll do is we're going to add in a multiplier for this to this LookVector by however many studs we want to give it. So in this case, if we want it to go, let's say 25 studs this way, then we're going to go back to our script and we're going to multiply this by 25. So now we have the part's position be inside of its current position plus the LookVector that this part is currently looking at, and multiplying it using however many studs we want it to move inside of this direction. So let's hit run and see our result. So as you can see, the part moved from wherever the part's direction was looking with its look vector, and it multiplied it by 5 studs going this way. And this is basically the desired result that we got from specifying its look vector and having it go inside of the direction that we wanted it to go with the specified number of studs. We can basically do the same thing with its right vector and its up vector. The right side being this, and then the up vector being the top part of the object. So we can go back to our script, and instead of making this the look vector, we could just make this the right vector. So instead of look vector, we can just say right vector, and then we can change the variable name to right vector, and we can change that like so over here, and we can go into the game and hit run, and this will basically do the exact same thing, but instead of going in the direction of its look vector, it's going to go into the direction of its right vector. And we can basically do the same thing with the up vector like so, and we can change the variable name here to up vector, and we can change that here. So let's hit run, and then what should happen is it's going to go up 25 studs in the up direction as expected, like so. So that is basically the introduction to some of the CFrame directional properties that you can use to help you make accurate calculations when it comes to this stuff. Alright, and so the last thing we're going to do in this video is change the CFrame of an entire model. Because up until this point, we were able to change the CFrame of individual parts. But you might ask, is this actually possible to change the entire CFrame of a model? And to that I say, technically yes, it is possible. But here's some things we need to know about. So if we, let's say, insert a model inside of Workspace, let's create a model inside of Workspace, and let's select this model. The model does not have a CFrame property in and of itself. So you might ask, how are we actually able to change the CFrame of an entire model? So pretty much how this works is that if we have a model full of parts, then what we need to do is specify a primary part that's inside of this model so that we can change the CFrame of that specific part to then change the parts of everything else with its CFrame, as long as we have some sort of constraint that's holding all the parts together. It might not make sense to you right now, but let me show you what I'm talking about. So now that we created this model, let's call this model I don't know, something dumb like my model. I'm not very creative with this stuff. And let's create two parts. So this one's going to be the first part. Let's change this color to blue. Let's duplicate this, put it over here, and let's change this one to red. So what we're going to do now is create something that's called a weld constraint that will hold these two parts together. Don't worry about not knowing what weld constraints are for right now. You could just follow along what I do. So when we hit the plus sign, let's insert a weld constraint. And let's click this, and there's going to be two properties, part 0 and part 1. Let's make part 0 our current part, and then let's make part 1 the other part that we're trying to hold together. And now this is indicating that these two are basically glued together. Let's take these two parts, put it inside of our model, and let's specify our primary part. So let's make this blue part our primary part. So we're going to rename this part to primary part. And what we're going to do is select our model, and there should be this property called primary part inside of pivot. Let's select this, and let's select our primary part. So now what we're going to do is insert a new script inside of here by hitting the plus sign, creating script. So let's make reference to our model by saying local model equals script.parent. And now what we're going to do is get our primary part CFrame, so basically the CFrame of this blue part over here. What we're going to do is get our current CFrame, which is local current CFrame equals model.primaryPart.CFrame. So now that we have this, let's change the CFrame of the specific primary part that we have in mind. So what we're going to do down here is we're going to say model.primaryPart.CFrame equals current CFrame times CFrame.new, and we'll just throw in some random positional CFrame right here by saying 0, 50, 0. All right, so now let's go into the game and let's hit run to see our change with this new part. Okay, so what ended up happening was that the CFrame ended up changing to be 50 studs above this direction, but because this part is not anchored, we saw that it literally fell down from the sky. So if we were to change this to something else like, I don't know, 50 studs in the X direction, let's hit run again to see our change. And as you can see, even though we only changed the C-frame of one part, we were able to change the C-frame of basically the entire model because of weld constraints and also our primary part. So that is a really important thing to know about when it comes to changing the C-frame of a whole model rather than just one part. So that is basically where I'm going to end it off here, and I hope you learned so much from the C-frame video, because this is a really long video, and I hope that you find a lot of value with this video for the future to come when you look back on this and apply what you learned from this video into your future projects, because C-frames are one of those things where you will have to understand how these things work, and this is basically going to be integral to the entire rest of your Roblox developer journey. If you're still confused about coordinates and how positions and orientations work inside of your Roblox games, then I encourage you to watch my Vector 3 video that I will have right here for you to watch, so go ahead and watch that if you haven't already. But with that being said, I will see you in the next episode. Take care.